Hello students. So welcome to our GATE score booster series. Myself Pradeep. I'll be taking the subject surveying here. Okay. So let us quickly go through some questions, some MSQs, some multiple choice questions and some NATs that are designed to cover your entire syllabus. Okay. Right. So please do try and answer. Right. If you are giving correct answers, let us discuss about it. Any questions you have, any doubts you have also in the keys that we are providing. Any doubts you have, you feel free to comment it in the comment section. So let's look at some questions here. Okay. So look at this. So this is from our basic concepts chapter here. Which of the following surveys and objectives are correctly matched? Right. Topographic survey, cadastral survey, city survey, engineering surveys. So are the objectives correctly matched? Topographical surveys. They depicts hills, rivers, woods, valleys. Yes or no? That is actually correct. So that statement is correct. Okay. Yes. So they are correctly matched. Cadastral surveys. What are cadastral surveys? They are conducted to represent legal boundaries. Locates boundaries of fields and houses. That's correct. Okay. Next step. City surveys for laying out plots, streets, water supply systems. Yes, these are all part of our urban planning. So that's also correct. Okay. Engineering surveys for collection of data for roads, railways, reservoirs, etc. That's also correct. So these are surveys conducted to collect design data for our civil engineering works. So that's absolutely correct. So the correct options here are A, B, C and D. Let's look at the next question here. In plane surveying, the limiting length of an offset depends on what? Right, so this is a question from our chain surveying, the first basic measurement. So the limiting length of the offset depends on which parameters? Accuracy required, yes or no? The answer is yes. Yes, it does depend on the accuracy of the survey. Because if you are doing a more accurate survey, you are using invar tapes, then the accuracy that you can achieve is very, very high. Right, which means we can put longer offsets. Right, scale of plotting, yes. We know that the maximum allowable error in plotting a detail is 0.025 centimeters or 0.25 mm. That is the value on the paper. So if this is the minimum most error that you are allowed to make on the paper, what is the corresponding distance to be measured in the ground? This is the minimum value on the paper. What can be the value on the ground? Who will decide it? The scale of plotting will decide it. Understand? The scale of plotting will decide it. So yes, definitely the limiting length of the offset depends upon the scale. The error in laying the direction of the offset. Yes, that's also a very critical parameter. Right, this is how my chain line is going. I am supposed to put a 90-degree offset like this. But the problem is the offset is not going at 90 degree, right? It is not going at 90 degree. It is having an error in the direction of the offset, alpha. So that alpha value also controls the error. Because I am supposed to, you imagine, I am supposed to put a 5-meter offset. So from here, the correct position of the offset should be this. But as the offset is going in this direction here, because of this error in the direction, my 5-meter offset will be somewhere around here. That is a plotted position. So that is the correct position. This is the incorrect position. So this becomes the error. Had this alpha value been smaller, the error also would have been smaller. Yes or no? Yes. So yes, it does depend. So this is also yes, depends. And finally, D is nature of ground. Yes or no? Yes, because you see guys, what is the degree of accuracy in chain surveying? Yes, it depends on the nature of the field condition. Under average conditions of the field, the degrees of accuracy that we can get is 1 in 500. But if you are doing your chain surveying in rough and hilly terrain, the degree of accuracy falls to 1 in 250. So nature of ground also plays in our degree of accuracy, therefore on the limiting length of the offset. So all these parameters depends on the limiting length of the offset, or they control the limiting length of the offset. Yes. Right, so this is one area which have not been asked in our GATE examination so far. Okay. Yes. Next up, consider the following with respect to compass surveying. So this is our second basic measurement, horizontal angle, and identify the correct statements. So they want the statements which are correct. Compass traverse requires both tape corrections and angular corrections. Yes or no? Yes. Because whenever we are running a compass traverse, we will require two data, the horizontal distances as well as the bearings of the lines. Now, there can be an error in the measured length. The tape can be too long, the chain can be too short. So, that conditions are possible. So, if it is mentioned, you will have to apply that. Similarly, right, corrections for angular measurements are also required, because there can be a local attraction for us. So, it has to be corrected. So, do they require both of this? Yes, they require both of this. That's correct. Local attraction affects all bearings from a station equally. So, local attraction at a station means every angle I measure from that station are equally affected. Yes or no? Yes. Right. Let's just look at that figuratively. So, this was the direction of the correct magnetic meridian. Okay. This is the bearing of my line PQ. This is the bearing of the line, let's say PR. So, these are two bearings that we are having. So, these are the bearings. Let me call it as theta 2 here, and let me call it as theta 1 here. Now let us bring in a small local attraction here, due to which let's assume that the meridian has rotated like this. So, that is the new meridian, or this is the actual magnetic meridian that we are having in the field. So, if the meridian changes the direction like this, what will be the bearing of this line PR? The bearing of this line PR will be measured like this. It would be theta 2 dash now, and the bearing of the first line will be this, that is what? Theta 1 dash. So, what is happening? Both the bearings are now increasing by the same amount. You see, whatever amount of rotation is this x degree, the same amount of change is coming in the bearings of the lines. Remember, the bearings change, but what happens to the included angle theta? That does not change, because local attraction affects meridians. Local attraction does not affect the line on the ground. And what is included angle? It is the angle between the lines. Okay. So, the line PQ and QR, they are remaining the same. Therefore, the angle, the included angle measured between two lines remains the same, but the bearing is measured from the meridian and the line. The meridian changes, that bearing changes. Understand? Yes. So, yes, that's correct. It affects, right, all the bearings from that station equally. Vertical angle a needle makes to the horizontal is called as magnetic dip. Yes or no? That is also absolutely correct. We know that this is supposed to be the body of our compass. This is the central pivot. You expect the needle to be horizontal. But sometimes, if the magnetic field lines are not parallel to the earth, the needle itself will not be parallel. So, you can see a vertical angle is formed. What do you call this vertical angle? You call it as dip. You call that angle as what? Dip. So, is that correct? Yes, that is also correct. True and magnetic meridians coincides for agonic lines. What are agonic and isogonic lines? Isogonic lines, iso matlab same or equal. So, isogonic lines joins points of what? Same or equal declination, whereas agonic lines will join points of zero declination. What is zero declination? Right. So, if I am saying that this is an agonic line, what is the meaning? Right. The meaning is the declination is 0 there. What do you mean by declination? Declination is the horizontal angle between the directions of true meridian and magnetic meridian. And for this agonic line, that declination is 0. There is no horizontal angle between true and magnetic meridian, which means the true and magnetic meridians are coinciding. True and magnetic meridians are coinciding. That is the meaning. So, is that statement correct, guys? That is also correct. So, which are the correct statements here? Again, A, B, C and D, all of them are correct. Yes. Right. Now, let us look at another question from our plane table surveying, guys. Look at this. In plane table surveying, orientation is not required in the radiation method. Yes or no? Yes, that's a very important point. Because remember, guys, when do I go for radiation method? What is the field condition for radiation method? Radiation method of plane table surveying is adopted only when the points to be plotted are intervisible and accessible from where? From one single station. The points to be plotted, I can see all the points, they are intervisible. I can measure a chain, I can put a chain between the station and the point in the field, I can measure the distance, right? That means they are accessible, and both these conditions have to be satisfied from a single instrument station. So therefore, orientation is not required. The process of orientation is required only when you are shifting the instrument. That's correct. Resection is the best method to add new details in an existing map. That's absolutely correct. Okay, that's also correct. Because you see, right, in an existing map, the new details may not be present. The map might be some 10-15 years old. So whatever details that I plotted in that particular map, right, it might be outdated or it may not have the present details present. Okay, so after 10-15 years, whatever new development has come, whatever new structures that they have built, it's not represented here. I'm supposed to add it to this existing map. So I'll take this old map to the field, to the areas where the old buildings are still present. So I have the old buildings in the ground, I have the old buildings on my paper. I can go and stand anywhere in the ground with respect to these two details present. I can follow the rules given by resection, Lehmann's rule. I can get my plane table oriented and the new details can be added. Understand? That's also absolutely correct. Intersection method is best suited for forested regions. Guys, forested region means there is no intervisibility, there is no plane table surveying. There is no question of plane table surveying if you cannot see the points. Okay? Centering is not required for a very large scale plotting. See guys, that is also not correct. Because what is the suitability of plane table surveying? Right, remember guys, what is the suitability? The suitability is, right, small to medium scale of plotting. Right, small to medium scale of plotting. So the plane table surveying is best suited for small to medium scale plotting. Right, because in small scale plotting, the error due to inaccurate centering is negligible. The error due to inaccurate centering is what? Negligible. But as the scale becomes larger, the effect of this inaccurate centering will be more, so it is not really suitable. So here the correct answers should be what? A and B. Right. So this C is not there guys. A and B is the correct answer. Okay? Yes. Next. The following consecutive staff readings, so this is from our leveling chapter, were taken from a benchmark of 125 meters along a continuously sloping ground with a 4-meter leveling staff. Let's look at the readings. 0.125, 1.115, 2.200, etc., right, up to 1.25. So identify the incorrect statements. So remember, they are asking which statements are wrong here. Right, now this model of question also they have not asked in our GATE examination. So please pay attention. Try to give me the answers as well. So the ground is sloping up. That's the first question. So if the ground is sloping up, what should happen to the staff readings? The staff readings should decrease. Correct now? So if the ground is sloping up like this is where your instrument is. This is how your line of sight is. Right? As I go up like this, what is happening to my staff reading? It should be decreasing. So this is something like 3 meter. This is something like 2 meter. This is something like 1 meter. This is something like 0.5 meter. This should happen. Staff reading should decrease. Let's look here. 0.125, 1.115, 2.2. What is that? Staff reading is increasing. So if the staff reading is increasing, the ground is sloping down, guys. Right. So try to understand. My staff readings are increasing. Staff readings are increasing, which means your ground should be sloping down only. That's the first point. So is that statement correct? No, that statement is not correct. There are two change points here. So let us identify the staff readings, guys. So what is the first staff reading? First reading, right, is from a benchmark. Therefore, first reading is always a backside. And the last reading is always a, let us write it as foresight. Okay. Now 1.125, ground sloping down, 3.98, after that 0.5. Remember, my leveling staff is only 4 meter. So almost that 4 meter length has been reached, right? So reading has decreasing, increasing, ground is falling down, the staff reading is increasing, and up to 4 meter only you can take the reading. Beyond this point, if you keep the leveling staff, the 4 meter mark of the leveling staff will go below the line of sight. The line of sight is horizontal, the 4 meter mark will go below the line of sight. So you will have to shift the instrument. So what is this? This is your foresight, and who is this? That is your backside. And all the readings between this back side and this foreside should be represented as intermediate side. So tell me guys, how many change points are there? Only one change point is there. So is that statement correct? There are two change points? No, that is not correct. There is only one change point. 3.500 meters is a foreside. 3.500, no, it is not a foreside, it is an intermediate side. Next, the reduced level of the last point is 120.39. So they are asking you for the RL of the last point. So how can we find the reduced level of the last point? By simply applying the arithmetic check. The summation of all back sides plus, right, the summation of all back sides minus the summation of all four sides minus the summation of all four sides should be equal to what? The last reduced level minus the first reduced level. Okay. So guys, who are the back sides here? 0.125 and 0.5. So 0.125 plus 0.5, right, minus, who are the four sides here? The four sides are 3.985 and 1.250. So 3.985 plus 1.250 should be equal to last reduced level. That is what they are asking, right, minus, right, it is starting from a benchmark of 125 meters. So what is the first reduced level, guys? That is 125 meters. So let us solve this and find out the last reduced level. Okay, so let's do that, guys. So 0.625 minus 3.985 plus 1.250, right, plus 125. So I am getting the last reduced level as 120.39 meters. 120.39 meters. Okay, so what are they asking? So the last reduced level is 120.39. That is correct. Finally, what are they asking? They are asking which of the statements are incorrect. So the incorrect statements are A, B and C. The incorrect statements are A, B and C. Alright, so this kind of question they have not yet framed in our GATE examination. So please try to note it, especially the kind like this. And one more type they have not asked us, calculating the gradient between the first and the last point. Okay, so that also you can try it. Yes, right. You can find such questions in the test series. Just please go through that. Okay. Yes. Right. Arrange the order of permanent adjustments of a theodolite. So this is question from theodolite. Okay. Yes. So plate level test, crosshair ring test, bubble tube adjustment test, spiral test, collimation in atmosphere test, and vertical arc test. So they are asking the correct order. So remember guys, whatever permanent adjustments that we have for a theodolite, they have to be done in a given order, because that's the practice. If you don't follow the order while trying to get one relationship, the other relationship may be getting disturbed. Therefore, it is always suggested you follow the correct order. So what is the first step that we do? First step is plate level test. Okay, so I'll go like this. First one is plate level test, followed by the second one should be crosshair ring test. So who is the crosshair ring test? That is 2. Okay, after crosshair ring test, the third test that you are supposed to do is collimation in azimuth test. Collimation in azimuth test, that is number 5. After collimation in azimuth test, the fourth test that you have to do is your spiral test. Fourth test that you have to do is spiral test, that is number 4. After spiral test, you have to check the last fundamental relation, that is the line of sight being parallel to the altitude level axis being parallel to the line of sight when it is horizontal, right, and the vertical circle at that time should read 0, 0. So that two conditions are checked by number 1, the bubble tube adjustment test. So bubble tube adjustment test is number 3. Okay, and the last test is what? Is our vertical arc test, where we are checking when the line of sight is horizontal whether the vertical circle is reading 0, 0 or not. So the last test would be vertical arc test. So the correct order is 1, 2, 5, 4, 3, 6. So 1, 2, 5. So 1, 2, 5. Yes, B is coming, and 4, 3, 6. 4, 3, 6. Yes. So the answer is what? Option B here. Okay. So that is the correct order. Okay. Now guys, we have not got too many questions from Theodolite in our previous years, right? It is part of our discussion, Theodolite, it is part of our syllabus, but recently only we started getting questions from Theodolite. If you look at the last few years of paper, you can see that they have framed questions around the vertical angle. Okay, they have framed questions around the vertical angle. So this is one area that you can expect question. The fundamental relation is one area that you can expect a new question, or anywhere from the terminologies they can frame a question. So just to go through this theoretical part, right? Next up, look at this, the combined correction. There is a previous year question you can find where observations are taken towards the top and bottom of the tower, and they are asking us to neglect the combined correction. So here we will take the combined correction. Okay, right. So what kind of angle we are having here? 30 degree, and more importantly, it was an elevation angle. It is an elevation angle. So let's just draw the figure here. So it has to be an elevation angle, means the ground has to look something like this. So that is the top of the mobile tower T. Okay, yes. This is where our theodolite is. Okay, with respect to the horizontal line of sight, the vertical angle I am getting towards the top of the tower is what? 30 degrees. Now, what is the staff reading, guys? The staff reading held at a station of reduced level 180 meter was 2.225. So with respect to the horizontal line of sight, when I keep a leveling staff at the reduced level of 180 meters, staff reading I am getting is 2.225 meters. Also, please look at this, guys. They are giving us the horizontal distance as well. What is the horizontal distance here? The horizontal distance is 1000 meters. So the horizontal distance is what? 1000 meters. So they are asking you what is the reduced level of the top of the tower after applying combined corrections here. Okay. So the first job that we have to do is find out the vertical distance V here. Okay. So what is V is equal to? V is equal to 1000 tan 30 degrees. Okay. So let us see how much is that. So I am getting it as 577.35. 575.350 meters. Okay, right. Now we need to apply our combined correction. So what is the value of the combined correction here? Right, 0.06735 into d square. What is d value here? 1000 meters, but I have to put that in kilometer so that I'll get the answer in meters. More importantly, what is the sign? Right, so here we are having a vertical angle of observation, therefore the correction is what? Positive. Vertical angle means positive angle. Elevation angle means, vertical elevation angle means positive angles. Vertical depression angle means negative angles. For elevation angles it is positive, and for vertical, depression angles it is negative. Okay, do not follow the negative sign that we follow for combined correction in spirit leveling. This is trigonometric leveling, so there is a difference. Okay, yes. So now what is the value of the corrected V? So the corrected V value will be 577.350 plus 0.06735. That is a corrected V value. So that should come as 577.4, right, 417 meters, right. That should be what this one should get. Now finally, what is the reduced level of the top of the tower? 180 plus 2.225 plus this value. Okay. So let me see whether you are getting that. So 577 point 2.225, 759 point. So the reduced level of the top of the tower is 759.642 meters, right. I hope my calculation is correct, right. This is the procedure. Okay. So here the point is how to apply the combined correction. Had it been a depression angle, this would have been a negative correction, and you should apply that correction to this vertical distance V. That's the point that here. Up to 2 decimal points you have to report the answer. Okay, guys. Yes. Next, please read this. So this is again a question from our contours here. Which of the following statements about contour lines is incorrect? So please be careful. Whenever we are talking about multiple select questions, we have to be very careful. We always have a tendency to select the correct statements, but sometimes they may ask you to select the incorrect statements also. Be careful there. Two contour lines do not intersect except in the case of an overhanging cliff. Is that correct? That statement is correct. So that statement is correct. Two contour lines do not intersect. They generally don't intersect. When do they intersect? They will intersect only in the case of a overhanging cliff or a cave. Okay. Contour line must close onto itself, not necessarily within the limits of the map. So that is also correct. A 100-meter contour line should start from one point and go to that particular starting point. It has to, but not necessarily within the scale of the map. Matlab, if this is the map is showing only one small portion of your area, right? It is showing only one small portion of the areas. So it may not show, right, the remaining portion. But you should not be under the impression that the contour line is stopping here. No, it actually continues like this. It actually continues like this. But within whatever limits that we are looking at the area, within that scale, it may not be completely visible. But please remember, it cannot go and randomly stop. Okay, yes. Equally spaced contour lines represent a uniform slope, yes. While widely spaced contour lines indicate a gentle slope. That is also correct, guys. That is correct actually. Okay, so because whenever the spacing is uniform, the horizontal equivalent is uniform, which means the slope is uniform. If the spacing between the two contours are very, very large, what do you mean by that? Two different elevation, 100-meter contour and let's say 90-meter contour. They are very, very far, which means it is a very gentle slope. If the distance between this 100 and 90-meter contour is very less, right, that means two different elevations are very, very close, it's a steep slope. Understand? Watershed or ridge line crosses contours parallel to them. No, if crossing has to happen, the lines cannot be parallel. That is basic common sense. If crossing has to happen, they cannot be parallel. And remember, the ridge line, watershed line, valley lines, they'll always cross contours at 90 degrees, guys. Remember, that's a very important property of contours. So that statement is wrong. So they are asking you for the incorrect statement. The only incorrect statement is D. So this is a multiple choice question. Okay, right. Be careful there. Okay, guys. Next up. Which of the following, consider the following statements and identify again the incorrect statements. Tachometric observations require slope and pull correction. Yes or no? Absolutely not. Correct now? Right. You see, guys, pull correction and our temperature corrections, right? They are generally, especially the pull correction is applied for what? For your chain surveying. Okay. Yes. Temperature corrections are applied to my total station readings as well as my chain surveying readings, because the chain can be, right, disturbed by the temperature. Similarly, in total station, when you are using electromagnetic radiations, they are getting affected by temperature as well as pressure. So there also we'll use it. But here there is no such corrections, just an optical device. Tachometer is an optical device, it is not an electronic device. So we cannot really apply that. Okay, right. Next up, subtense bar tachometry is more suitable for longer sight distances. Is that statement correct, guys? No, that is also not correct. The subtense bar itself is roughly 2 to 3 meters long. So if you keep this, subtense bar horizontally, let's say 2 meter, some 2 kilometers away, what is the horizontal angle that you can measure between the two targets? Right? Nothing will be there. This 2 meter distance at a distance of some 2 kilometer does not put any considerable angle for the theodolite to measure. So that the method fails. Okay, so it's also not possible. It's only possible for few hundred meters. Tangential method of tachometry is more accurate than fixed stadia. No, guys, it is not. It is not accurate because you see, first of all, tachometry is adopted when the ground is undulated, the ground is uneven in hilly terrain. And in this hilly terrain, in tangential method of tachometry, you will have to observe my target staff 2 times. So literature says there is a high probability that tripod legs can get disturbed in between these two measurements, which means your entire accuracy will be gone. But when it comes to your stadia method, even though the field conditions remains the same, I'll have to take observation towards my leveling staff only once. So there is a less chance of the instrument getting disturbed. So after taking the observation, even if the instrument gets disturbed, there is no problem. Because after the observation, my work is completed. Only one is required. But in tangential method, 2 times you have to observe. And therefore, it is a slow method also. So no, fixed stadia method is the most accurate method. Stadia diaphragm has 2 additional horizontal crosshairs. That is absolutely correct. Because generally, our crosshairs are 2, vertical and horizontal. To make it to a stadia diaphragm, we provide 2 more additional horizontal hairs. That's absolutely correct. So that statement is correct. But they are asking you for the incorrect statements, which are A, B and C. Right. So our incorrect statements are what? A, B and C, guys. Right. Next step. Identify the correct statements. Okay. So the planimetric constants are dimensionless. Where do I use a planimeter, guys? I'll use a planimeter, right, in our area calculations. To calculate irregular areas from a map or a plan, I'll use a planimeter. What is the planimetric area formula? Area A is equal to M into final reading minus initial reading plus or minus 10n plus C. These are the formulas. Now here, right, these 3 are readings taken from the graduated drum, whereas M is the multiplying constant and C is the additive constant. Remember, the additive constant has no unit, but this multiplying constant will have units either in millimeter square or in centimeter square. Right, so please remember that. So the planimetric constants are dimensionless, that is wrong. Right, the multiplying constant has dimension, it has area dimensions. Right, there are some formulas also to calculate, but you forget about it. So that statement is actually wrong, guys. Right. Area of 0 circle is not included when the anchor point is outside the area. So guys, what is the area of 0 circle? You see, area of our 0 circle A0 is equal to M into C. That is the area of the 0 circle. Now you take this particular formula and multiply this M and C here. So then what is area? Area is equal to M into, right, final reading minus initial reading plus or minus 10n, and I'll take the C outside the bracket. So I should write plus M into C, right, plus M into C. So where this M into C is nothing but the area of the 0 circle. But remember, whenever the anchor point is outside the area, the value of C will be taken as 0. So if the value of C is taken as 0, this entire area will be gone. Area of 0 circle will be gone. So remember, whenever the anchor point is outside the area, 0 circle area is not considered. So what is 0 circle? Right, what is the theory behind that? You can just go and find it out. Simpson's rule is applicable. So is that statement correct? That statement is correct. Simpson's rule is applicable only for odd offsets. Yes, famously we know it is applicable only for odd offsets. Meridian distance is the distance of the end point of a line from the reference meridian. So if this is a closed traverse that we are having, right, in our meridian distances method, we will assume a reference meridian passing through the end station, this this western station like this. What is the meridian distance of a line? Remember guys, meridian distance of the line, it is actually the distance of the midpoint of the line from the reference meridian. So that is the meridian distance of first line. If this is the midpoint of the second line, this is the meridian distance of the second line, right, so on and so forth. So remember, meridian distance is measured from the reference meridian to the midpoint of the line. What does the statement says? To the end point of the line. So that statement is wrong. So which are the correct statements here, guys? B and C is correct. Right, they are asking you for the correct statements. The correct statements are what? B and C, guys. The correct statements are B and C. Right. Next step. Choose the incorrect statements. So here they are asking us to find out the incorrect statement here. A closed traverse is most suitable for a narrow strip of area. So if I am giving you a narrow strip of area, for example, this is a railway line 100 kilometers long. To survey this, do you go for a closed traverse or an open traverse? Right, we have to go for what? An open traverse, guys. Closed traverse is best suited for smaller extent of areas. For example, you want to find the area of a building, right? You want to find area of a pond or a lake. For smaller extent of area, you go for this closed traverse. For narrow strip of lands, you have to go for an open traverse. So that statement is wrong. Free needle method is better than fast needle method. Okay, right. See, fast or fixed needle method and free needle method that we have. The problem with the free needle method is that local attractions are there, and at every traverse station you need to find the direction of meridian. At each and every traverse station A, B, C, D, you will have to establish the direction of magnetic meridian from scratch. But in fast or in the fixed needle method, that is not the case. You establish the meridian at the starting station. Now what you do is, you make the other meridians parallel to this. So the effect of local attraction will not come. This is much more faster and much more accurate. Therefore, fast needle method is more suitable, more accurate than our free needle method. Fast or fixed needle method is more accurate than our free needle method. So is that statement correct? Free needle method is better than fast needle method. No, that statement is incorrect. The coordinate method of plotting of a traverse is usually employed. Yes, that is correct. Why don't we go with the angle and distance method? Right, why don't we go with that? Because the disadvantage of the method is, if there is a closing error, you will identify its presence only at the end of plotting. You have to plot some 10-20 lines only at the end to realize you have closing error. Understand? So this is eliminated by our coordinate method. So we will have one condition: the algebraic sum of the latitudes and the departures should be equal to 0. Consecutive latitudes, consecutive departures, their sum with sign should be equal to 0. So for this, you don't have to draw any lines. In the beginning itself, we can check this. Departure of the line is the projection on the reference meridian. So whenever we are talking about reference meridian, we are talking about the north-south meridian, guys. Reference is north-south only, right? East-west is buy one get one free. When you take the right line or the reference meridian north-south, then you will get this east-west free. So if you take a line AB and if you project this line AB onto your reference meridian, on the reference meridian, what is this length of projection called as? Latitude, guys. And what is the length of this projection called as? Departure. It is towards the east, so that is positive departure. This is towards the north, therefore that is positive latitude. So the projection on the reference meridian is latitude and the east-west axis is your departure. So depending on that, that statement is wrong. Departure is the projection of the line onto the reference meridian is wrong. It is a projection onto the east-west meridian, guys. Okay? Yes. Next, so the correct, incorrect options are A, B and D. So A, B, D is your correct answer. Right. The long chord and tangent for a circular curve of radius r will be equal if the deflection angle is dash. So you see, when it comes to curves, if you look at the previous year gate questions, they are framing a lot of questions from tangent distance. You can just do it yourself. Go and look at the previous year gate questions. Most of the questions are in and around the tangent distance. So similarly, we can frame a question like this. The long chord and tangent distance are equal to what deflection angle? So the long chord is represented by L, tangent distance is T1I or IT1, IT2, both are correct. Long chord is what? 2R sine delta by 2, correct? It is equal to, what is tangent distance formula? R tan delta by 2. So this R and this R will get cancelled. So 2 times sine delta by 2, okay, should be equal to what? Tan delta by 2, which can be written as sine delta by 2 by cos delta by 2. So from this, the sine delta by 2 will get cancelled and you will get cos delta by 2 is equal to what? Cos delta by 2 is equal to 1 by 2. which means delta by 2 should be equal to 60, which means delta is what they are asking, should be 120 degree. Okay, very famous question. In our state services and all, you can find such simple questions like this. If you are lucky enough, you will get a question like this. Okay, yes, very simple question. Okay, FM curves. Next, which of the following with respect to the weights of an observation, consider the following with respect to the weights of the observation, and they are asking us to find out the correct statement, guys. The correct statements. So look here, guys, errors and adjustments is also a very important topic in our GATE examination. We've got some very good questions, like very recently also in our GATE papers. Okay, now weight is one area that they have not asked recently, right? They are asking more about the propagation of errors. Okay, errors in computed quantities is what they are generally asking. Either they will ask for absolute error or probable errors. This weight is one area from which they can frame question. Okay, both numerically and theoretically. There are some rules, there are some laws that we have to follow for weight, laws of weight, LAWS. Okay, so based on the laws, there can be some theoretical questions which can be framed as multiple select. Based on the laws, you can also get numerical questions also. There was one question previously asked. Let's look at this. The weight of an angle varies directly as the number of observations are made on the angle. Yes, if more number of observations are made, more weightage will be coming. More repetitions are there, more number of trustworthiness will be there. For an angle, right, repeated for great number of times, so you are measuring it large number of times, right, we know that infinite number of observations will consider. The weight is inversely proportional to the square of the probable error. The weight is inversely proportional to square of probable errors. We know that. What is the relationship between weight and correction, guys? Weight and correction are inversely related. You can look into this mathematically, or you can look at this conceptually also. Right, what do you mean by weight? Weight means trustworthiness. Weight means trustworthiness. So if you have a quantity that is more trustworthy, you give it less correction. If you have less trustworthy, you have to give more correction. So the relation is inverse. Right, mathematically also you can see it. You can just go and look at the notes. Right, you can just read the material. Yes. Now here they are saying, right, weight is inversely proportional to the square of probable errors. We know that from the rules of adjustments that correction is proportional to, whenever I give you quantities A, B, C, D, etc., with their probable errors EA, EB, EC, etc., how should I give corrections? Right, the corrections to observations are always proportional to the square of probable error. So correction and probable error are directly proportional. So which means correction and probable error are directly proportional, which means weight and probable errors are inversely proportional. So weight is inversely proportional to the square of the probable error. That is correct. That statement is correct. For a line of levels, the weight inversely varies with the length of the route. Again, correction applied for a line of levels are directly proportional to the length of the route. So correction is directly proportional to the length of the route. So from this, probable error and length are right. What is the relation? Probable error is directly proportional to the square root of length of the line, which is the nature of accidental errors. Yes. So that statement is actually correct. And weight is directly proportional to variance. Right. Now that is incorrect, because again, variance is a measure of error and weight is a measure of correction. So if more weight is there, more trustworthiness is there, lesser error, lesser variations should be there. Okay, so that is also right, not correct, guys. Weight is not related to variance. Weight is not related to variance. Variance is a measure of what your error. Variance V is equal to the square of your standard deviation. Standard deviation itself is an error. Root means square error. So weight is a term related to error, whereas weight is a term related to trustworthiness, and variance is talking about error. So they are not directly, but they are inversely proportional, guys. So this statement is wrong. So the correct statements should be A, B, and C. Okay? Yes. Right. In aerial photograph, so we are talking about photogrammetry here, the scale is always constant. Instantly wrong. The biggest problem with any aerial photogrammetric surveying is that the scale is not constant. We know that scale of an aerial photograph is not constant. Why? Focal length of the camera does not change. Flying height of the camera does not change. But what changes is ground elevation. Each and every point in the photograph is having a unique value of elevation. Therefore, each and every point in the photograph will have a unique value of scale. So, the scale is not constant, guys. Relief displacement is 0 below the exposure station. That's absolutely correct. Because, right, if this is my exposure station here, right, just below this exposure station, if I am having a tower that looks like this, right, what will happen to the top and bottom of the tower? Both the top and the bottom will appear at the same point. So, there is no relief displacement. Had the tower been here, top of the tower will appear here, bottom of the tower will appear here, which means there is relief displacement. So, that statement is absolutely correct. Stereoscopic vision is not possible without overlap. Yes, right. Stereoscopic, that statement is correct. Stereoscopic vision means it is the vision which enables us to perceive depth, guys. Right. It perceives depth. It gives us the impression of depth, distances, just like the vision that we are having. We have two eyes, that is binocular vision or stereoscopic vision. Had you had only one eye, then you will not be able to perceive distances towards object. Driving will be very difficult, right? Playing games will be very difficult because it needs you to know the distance between them. So, that is why two eyes are there for that stereoscopic vision, for parallax. So, that statement is correct. Drift is absent in aerial photograph. You can never say that. We can actually never say that whether drift is present or not. It may be present, it may not be present. If there are some good strong winds present, right, the aircraft might drift away from its original path. So, drift is absent is not a correct statement to say. So, the incorrect statements here would be A and D. Okay, guys, the incorrect statements here would be A and D. Let us look at this question with respect to remote sensing. Please read this. With respect to the concepts of remote sensing, identify the correct statements here. Identify the correct statements. Senses of vision, sound, smell. Vision, sound and smell are examples of remote sensing for humans. Yes, that's correct. Right. Without touching a water bottle, I can say whether it is cold or not. I'll be able to say that. By hearing the sound, I can say whether it is a water that is falling or is it a metal piece that is falling, because they have different sounds. I don't have to touch it. Right. From smell also I can identify, right, what kind of material I am having in front of me. Okay, now whether it is chicken biryani or whether it is not chicken biryani. At least that much I can say. So, smell also a sense of remote sensing. Wavelength of electromagnetic radiations are proportional to temperatures. Right, is that correct? That's correct. That is as per the Wien's displacement theory. The wave theory says that wavelength is inversely proportional to frequency. Right, the quantum theory says that quantum energy is directly proportional to frequency. So, there was a previous question very recently in engineering services. They asked the relationship between quantum energy and wavelength. They are inversely proportional. Wien's displacement theory says that wavelength of your radiation is inversely proportional to the temperature of the medium you are traveling with, or the product of wavelength and temperature is always a constant called as the Wien's displacement constant. So, what does this statement says? Wavelength are proportional to temperature, right? So, you see here it is inversely proportional. So, that statement is wrong. They are inversely proportional to temperature, guys. X-ray imaging represents an example of active remote sensing, right? X-ray imaging represents an example of active remote sensing. Is that statement correct? Yes. Right. So, without touching your bones, they are able to generate image. They are able to say whether you are having fractures or not. So, that is active remote sensing only, and the X-ray radiations are generated by the system, by the X-ray machine. That's correct. Remote sensing works on the principle of spectral refractions. That is wrong. Right, that is wrong. So, remote sensing does not work on the principle of refraction. It works on the principle of spectral reflection, guys. And they are asking us to identify the correct statements. So, what are the correct statements? They are A and D. Okay, right. So, yeah. So, this is wrong, guys. This is wrong. So, they are sorry. Correct statements are yes, A and C. This is wrong. B is wrong. Okay, yes. Next, right. So here also, which of the following are correctly matched with respect to triangulation surveys? So if you are looking at triangulation surveys, which of these definitions are correctly matched? We have main stations, pivot station, Laplace station and satellite station. What are main triangulation stations? Main triangulation stations are stations which I occupy with instruments and I'll take observations so that I can carry forward my network of triangulation. So control points for triangulation networks, that is correct. Okay. Pivot stations, points not for observation but for continuation of triangulation work, that's correct. So pivot stations, the problem is you never occupy pivot station, but angles towards pivot station you have to take, so that in the future if you want to expand the network of triangulation, that is possible. Understand? But the problem is, since you are not occupying it, we cannot get complete checks on the pivot station, therefore we avoid it. In our triangulation, in field we avoid it, but in theory you should know. Right, next one is Laplace stations. Laplace stations are triangulation stations at which we take astronomical observations. Okay, so points to provide additional rays to intersected point. No, that is not correct. Right, that is actually the definition of subsidiary stations, subsidiary triangulation stations. Okay, that is not the definition of Laplace station. Satellite station, points close to main stations to avoid intervening observation. That is exactly the definition of satellite station. So whenever we are unable to occupy a main triangulation station, we try and take a station very close to it and we'll take observations from that station. And finally, all the observation taken from the satellite station, right, will be represented as that made from my main triangulation station. We do calculations so that we can get the angles from the main triangulation station. Reduction to the center we have to do. Okay, so the correctly matched pair is A, B and D. Yes, that's correct, A, B and D. Okay guys, so these are some questions that are covering most of the topics that we have. We have framed questions in such a way that they are not really from any of our previous year models. Okay, so please do try and solve these questions once again. Thanks a lot, all the best.